Planetary scientists find ancient ice caps beneath Martian North Pole. Planetary researchers using data from the Shallow Radar (SHARAD) instrument on NASA's Mars Reconnaissance Orbiter have discovered rich deposits of water ice and sand hundreds of million years old beneath the current ice cap in the North Polar region of the Red Planet. Published journal Geophysical Research Letters, the findings are important because the layers of ice are a record of past Martian climate in much the same way that tree rings are a record of past climate on Earth. University of Arizona's Professor Jack Holt and Stefano Nerazzi from the University of Texas at Austin found layers of sand and ice that were as much as 90% water in some places. If melted, the newly discovered ice would be equivalent to a global layer of water around Mars at least 5 feet, 1.5 meters, deep, which could be one of the largest water reservoirs on the planet. We didn't expect to find this much water ice here. That likely makes it the third largest water reservoir on Mars after the polar ice caps, Nerazzi said. The scientists suspect the layers formed when ice accumulated at the poles during past ice ages on Mars. Each time the planet warmed, a remnant of the ice caps became covered by sand, which protected the ice from solar radiation and prevented it from dissipating into the atmosphere. Planetary researchers have long known about glacial events on Mars, which are driven by variations in the planet's orbit and tilt. Over periods of about 50,000 years, Mars leans toward the Sun before gradually returning to an upright position, like a wobbling spinning top. When the planet spins upright, the equator faces the Sun, allowing the polar ice caps to grow. As the planet tilts, the ice caps retreat, perhaps vanishing entirely. Until now, they thought the ancient ice caps were lost. The new findings show that in fact significant ice sheet remnants have survived under the planet's surface, trapped in alternating bands of ice and sand, like layers on a cake. Our research provides new, important insights into the exchange of water ice between the poles and the mid-latitudes, where we previously confirmed the presence of widespread glaciers, Professor Holt said. Surprisingly, the total volume of water locked up in these buried polar deposits is roughly the same as all the water ice known to exist in glaciers and buried ice layers at lower latitudes on Mars, and they are approximately the same age. Studying this record of past polar glaciation could help determine whether Mars was ever habitable, Nerazzi added. Understanding how much water was available globally versus what's trapped in the poles is important if you're going to have liquid water on Mars. You can have all the right conditions for life, but if most of the water is locked up at the poles, then it becomes difficult to have sufficient amounts of liquid water near the equator.